this is Jo from Maths Tutor Me. Today we're going to start a topic on simultaneous equations. And there are three different methods that I'm going to teach you for solving simultaneous equations. The first method today is called the graphical method, and the name kind of explains it. We're going to be solving these equations by graphing them. Now, what we have is two equations, and to solve simultaneous equations we're trying to find the value for x and the value for y that works for both equations. So using the graphical method means we want to graph the two lines and find the point at which they intersect. Now, if you're doing simultaneous equations, I'm guessing that you have done some graphing of straight lines before. And hopefully you know that there is three different methods that you can use for graphing straight lines. The first method that is usually the first method that you learn is to use a table of values. And you substitute values into your equation, you substitute x values in, and you find y values. Okay, then hopefully you learned the gradient intercept method and also the xy intercept method. Okay, so the second and the third method are the ones that we're going to be using today. Using a table of values is what I consider kind of your backup plan. If you're not sure how to sketch a graph, you go to your box of values. But using the xy intercept method and the gradient intercept method should be much faster if you know what you're doing. Okay, so let me show you those methods today. So my first question here, I have two equations, y equals 2x minus 3 and y equals minus x. Now this equation is in the form y equals mx plus b. Okay, hopefully you've heard of that before, where the number on the end, the minus 3 here, we call that b, which is our y-intercept. The number in front of the x, which is a 2, is m, our gradient. Now to sketch from that, if my y-intercept is minus 3, you do that first. You go to your y-axis and you go down to minus 3 and you put a line, a dot or a cross there to mark that spot. Okay, so you always do the y-intercept first. Then to do the gradient is 2. Now hopefully you remember that gradient is rise over run. So if I have a gradient of 2, that means I'm going to rise 2 and run 1, because 2 over 1 is just 2, but we need a rise and a run. So if there's no denominator, you just make it a 1. So you start from your y-intercept, which is why you have to do that first. And we rise 2 like that, and we have to run 1. Now, it's important that you recognize that that's a positive gradient, and we have to go towards the positive direction when we do the run. So rise 2, run 1. You only need to do it once, but you can do it more if you want to. Rise 2, run 1. And we can get a few crosses on our grid there. Now I had pre-drawn this grid to save us some time. You can pause the video if you want to be drawing your own grid. It's best to have grid paper whenever doing these questions in order to get it as accurate as possible. So let's draw as neatly as we can a line going through those crosses that we've made. So that's our line y equals 2x minus 3. Okay, for the second line here, y equals minus x. Well, there's actually no number here on the end, which means my y-intercept is 0. So right here in the middle, my y-intercept is 0. My gradient is a negative 1. That means I need to rise 1 and run 1, but to the negative side. So starting from your y-intercept, rise 1 and run 1 to the negative. Okay, some people will tell you to go down when it's negative. I always say you rise, because it's always rise over run. You always rise the number. If it's positive, you go to the positive numbers on the right. If it's a negative gradient, you go to the left. So rise 1, run 1. I can do it again, rise 1, run 1. Okay, and there is my line that I can put through all of those. Use your ruler, neatly as we can. Okay, so there's two lines that are intersecting at a point. That point is my solution. So the last thing I need to do is write down my solution. Now it is a point, so I can write it as a coordinate. It is the point x equals 1 and y equals -1. So my solution is 1, -1. Okay, let's try that again in question 2. This time our equations aren't in the gradient intercept form. That would have to be in the y equals mx plus b form. I have 3x minus 2y equals 9, okay? So I'm going to use a different method this time. I'm going to use the Xy Intercept method. To do that, just starting with this first equation here, I am going to see what happens when x is equal to 0. If I make x equal 0 in there, I would have 3 times a 0 minus 2y equals 9. Well, 3 times 0 is nothing. And to get the y by itself, I would divide by -2, which would give me y equals -4.5. Okay, that is one of my intercepts. I also need to see what happens when y is equal to 0. Into the same equation, now I have 3x minus 2, the y is 0, so put that in there, equals 9. 2 times 0 is nothing, so I have 3x equals 9, so I divide by the 3, and that tells me that x is equal to 9 divided by 3, which is 3. Now this is just to sketch this first line. When x is equal to 0 on my graph is right here in the middle, y is equal to -4.5. Okay, that gives me my y-intercept. When y is equal to 0, x is equal to 3. Gives me my x-intercept. So I have the two crosses there. That's all you need to do a straight line, to draw a straight line. Draw a line in between. And there's my first line. Now we have to do that all again for the second one. So let's draw a line down here. Okay, so let's start with when x equals 0. Putting that into the second equation, that would give me 0 plus 2y equals -4. The 0 doesn't do anything. If I divide by the 2, that will give me y is equal to -2. Then we try and see what happens when y is equal to 0. Following the equation, x plus 2, we put the 0 in for the y, equals -4. Okay, 2 times 0 is nothing, so all that's left is x equals -4. Let's sketch that. When x equals 0, y equals -2 is here. When y equals 0, x equals -4 over there. Okay, let's see how we go here. Use a ruler to draw a straight line. Then we need to try to read our solution. Okay, so my solution, we have to try and read off here as best as we can. X is probably about 1.2 and y is about -2.7. So you just do your best to read off the solution as accurately as you can. Okay, seeing as how you're reading this off a graph, it's not going to be a perfect answer when it's in the middle of the grid lines here like this. Okay, so this is actually not the best method of solving simultaneous equations. The algebraic methods that we're going to learn next are actually far more accurate. But just do your best to read off the solution as best you can on your grid, and if it looks reasonable, then you'll be sure to get full marks on any tests. Okay, so on the next page, here's some questions just like the ones we just did. So you've got the two methods here, so you can practice both methods of graphing straight lines. Turn off the video, have a try, and I will go through the answers in just a minute. Okay, so I've just quickly drawn some grid lines on there, my Cartesian plane on there. So let's sketch our first two equations here using the gradient intercept method. Y equals minus 2x plus 3. So it's the y equals mx plus b form. My y-intercept is 3. 1, 2, 3 goes there. My gradient is a negative 2. That means I need to rise 2 and run 1 to the negative side. So from my y-intercept, 1, 2 for rise and run 1. There it is. And try to neatly draw a line through those. Okay, now my second line, y equals x minus 4. Minus 4 is my intercept, and my gradient is 1. Rise 1, run 1. Could do that one a few times, that's a nice easy one. Okay. Alright, so best we can, let's read off a solution. X looks like it's maybe about 2.3, and Y looks like it's about let's say negative 1.6. Okay, again, it won't be completely accurate, but we just do the best we can. Alright, in question 2, let's use our Xy intercept method. When x equals 0 into the first equation, that would give us 3 times 0 minus y minus 2 equals 0. 3 times 0 is nothing. Now to get y by itself, let's actually move it across to the other side to make it positive, which would give me negative 2 equals y, or y equals negative 2. Then let's substitute in when y is equal to 0. That would be 3x minus 0 minus 2 equals 0. 0 doesn't do anything. Let's move the 2 across. 3x equals a positive 2. Then we need to divide by the 3. So x is equal to 2/3. Drawing that line, x is 0, y equals minus 2 is down here. When y is 0, x equals 2/3. Alright, so already this is getting tricky to be accurate. It's about there. Okay, looking at the second line, let's substitute when x equals 0. That would be 0 minus y plus 2 equals 0. Okay, the 0 doesn't do anything. Let's make the y positive, so y is equal to a positive 2. So effectively I've moved the y across to the other side, giving me y is equal to 2. When y is equal to 0, x minus 0 plus 2, okay, 0 doesn't do anything. So I have x plus 2, subtract the 2 to move it across the other side, x is equal to minus 2. Let's graph this. When x is 0, y is 2. When y is 0, x is negative 2. Okay. Now that actually looks like we've come up with quite a nice solution. It looks like, let's write it down. The solution, it looks like it's on the 2 there. X is 2. and y is 4. Okay, so as I said, the graphical method is not the most accurate, but it is a method that you need to know. If you join me next time, I'm going to start going through the algebraic methods. We're going to look at the substitution method, and we'll get some much more accurate answers. So join me then. I'll see you next time.